Hello. In this presentation, we are going to discuss the object detection in satellite images using YOLO version 2 deep learning. So, myself, Shadab Siddiqui, and with me, Deepak Kumar is here, and we are pursuing PhD, the Department of Electrical Engineering. So, this is a part of coursework, assignment 2 for deep learning, introduction to deep learning. So for this, we have taken the topic on object detection in satellite images using YOLO version 2 deep learning. So Deepak is going to discuss the introduction part.
In this object detection technique, first of all, we need some data set. So here in this project, we take a data set from Airbus Ship Detection Challenge data set, and that data is categorized into two folders. One is called training data and other is test data. That is separate two folder. In the train data set folder, 100 image of the ship taken from the satellite view image is included, and in the test set, in the test folder, 50 images of the different category for the same image of ship is stored. And further, we have used in this MATLAB code object detection using deep learning YOLO 2 version 2 deep learning, and applied the transfer learning process in that YOLO version 2. Where first of all, transfer learning. What is transfer learning? We have to understand that thing. And transfer learning is the process by which we use a pre-trained deep learning model, and some of the parameter we have to fine tune according to our need. That is transfer learning. And task of this example to use the dataset available training image and construct a ship detector using a deep learning and transfer learning method. Further, this presentation include these are the major topics, which are solution approach, settings, some of the prerequisites that we have to consider here, and use some of the inbuilt app of the MATLAB we have used for the image labeling, like data processing and pre-trained ResNet 50 deep learning, which is also in the available, and we have the some part of the deep learning of the ResNet 50 is taken as a feature extractor, and that is joined to the YOLO object detection network. So in this overall, we have tried to construct a model in which feature extraction from the ResNet 50 is taken and combined with the YOLO version 2 network. Solution approach includes these 5 basic steps, where first step is to use the image labeler to segment the SIP image. After that, data processing. Third step is applying pre-trained ResNet 50 deep learning for feature extractor, and fourth step is creating the training YOLO object detection network, and fifth final step is evaluating the network for the different type of images. One folder from the image training image and other is test image. So these are the setting in which one data folder is created, and in that data folder, 2 subfolder are created. One is called train folder, other is test folder, which have different images. Train folder have 100 images, and test folder having 50 different images from the train image. Now, YOLO version 2 pre-trained some weights are downloaded from this URL given here, and so these pre-trained weight is further utilized. We use that weight to train our network. And here image input size is defined as 224 cross 3, because this is the input size image for the ResNet 50 network. Now, image labeling is manually done by this image labeler app available in the MATLAB toolbox, where one by one selected image is one image is selected, and finally we have created an annotated bonding box and the name of this object is SIP. Like this, we have defined, and finally, these images and their labels are stored in back to the same folder created. These are the things. Again, data processing here in this step, two file name. One is called IMDS. This is the image file, and IBLDS. This is the label of this image. And combining these two files by the command of combine, we can create a data combined data. And total here number of image is 100, which we will going to use during the training. Now, this 100 image is transformed to the same size because 100 image may be of different sizes. So we need to transform all the image to of same size. We use this command where all the images are of 24, 24 plus 3. Now we can see here total 100 images with their bounding box of 6. If we want to see one by one these images, we can choose this slider command, and we can see here 42 number of images. This is resized and annotated image, which is zip indicated in this here two images, two object that is zip in this image. Now we have to use some feature extractor part from the ResNet 50. So from here, Sada will explain.
So thank you. We are having the ResNet 50 deep network that is used as a feature extractor. So in this, this is basically already pre-trained model. So we have taken. So ResNet 50 is compatible as told. That is having the input sizes of 224 cross 224. So we have transformed already. We have transformed all the images in this 224 cross 224. So in this ResNet 40, we got all these input and we applied to ResNet 50 model. So the feature will be extracted from this. So some of the you can say the tweak has been taken for the ResNet 50, which is available already. So total 177 layers are there in the ResNet 50. So we have just transformed into this. We have taken the few layer we have just omitted so that our model will work correctly. So we have taken the activation 40 ReLU. So this 40 ReLU is just taken at this point, and we have just omitted these you can say blocks. Just we have omitted. So we have taken up to this. So total size was 177. So that is reduced to 150. So after this, you can see activation 40. Just we are having the YOLO version 2. So before going to this. We have taken this activation network. So okay, so we have freeze all the weights of the feature extractor network. So whatever that previously before this activation 40 that was there, so we have all that we have freezed. So after this, we have created YOLO object detection network. So input size already defined. So we have taken the number of class which is equal to 1 and anchor boxes which is 7. So this number of classes and anchor boxes, input size, and all this will that will give us one layer, and this layer is providing us. You can see this is the analyzer which is giving us all this architecture detail. So which is shown here. Now we are going to train our YOLO object detector. So in the training, we have taken the stochastic gradient descent method, and we are going to train the YOLO and mini batch we have taken as a 12, and initializer learning rate is 10 to the minus 3, and maximum epoch which is taken as a 120. So this is considered here. And after that, we are going to train. So after training, we can see this. This is the number of epoch. This is the result which is showing here. So in this, we can see the first epoch we are getting the mini batch which is 6.71, and validation we are getting as 3.04. So loss which is provided in the first epoch, so 45.03, and validation loss is 9.03. So learning rate was 0.001. So learning rate we have fixed to 0.001. So after the just increase the epoch, so at you can see the epoch. If we increase the epoch, so this validation will be decreases, and the loss is also drastically reduced, and the validation loss is also reduced. So we can see here at the end of 120 epoch, we are getting a loss as approximately 2% loss we are getting. Okay, and so after this, we have analyzed this our network. So we are having different activation function which we are taken, the different layer we are taken, and learnable parameter which is also shown here. So now this is the different graph, same thing which you have shown here. So it is also giving us here.
These are the analysis of the different layer.
Yeah, these are the analysis
functioning.
of different layer which are functioning. So these are the what kind of padding we have done, what kind of activation function we have used, how many parameters which is there. So that is already these are things which is presented here. So now in the result part, so to evaluate YOLO detector on the training image. So in this we have run detector on image. So total images are 100 images. So we have taken I is equal to 1 to 100. We have chosen here, and it is detection result which is going for the first any ith boxes. So it is giving us boxes and score which is providing here, and for the label it is also the ith label which is providing here, and so here we can see this is the training result which we are providing. So after the training, we have combined all the images, 100 images in the grid. So in this we can say all the ship which is detected in the training. So already we have annotated this, but after having the test image, we should evaluate our unit how it is working or how it is working. So it is working or not. So we can see that we have taken the image from the test images, and total 50 images were there. So all these 50 images, few images are having the ship and having the object, and few images are not having the object. But already all these objects are which is properly you can see the annotated is giving the in the result set. So it is properly detected.
So although some of the images are not correctly identified, but mostly because this is the very less data set is provided during the training. So these we can see here, these not correctly identified, but here in this number, 16, 17, 18, 19, 20, 21 number of images correctly identified. Here this one is correctly identified, this one is correctly identified. Some of the images correctly identified, but some of them not correctly identified because less of the very less training available during.
So we can see here the
If we
20th
select the
image.
number of
So
images,
we can
here,
say here we have taken the individual test image. So if you see the 20th image, it is properly detected. So properly it is giving the ship detection. So here we can see it is not very much accurate, but yes, it is providing the result because we have less number of training images. If we increase the training image, we can get the good result. So although we are getting the this one. So finally, to conclude this, we have went through the step-by-step development of the deep learning solution, and we have taken the MATLAB approach to solve this problem. So YOLO network already successfully detected several ships in the satellite images, and although some of the ships of the test image are not detected because of the shortage of data, shortage of training images. So if we increase the training image, we can get proper data. So thank you.
so these are the references